Hello everyone, welcome back to my YouTube channel. I'm Arya Bayu and my partner
And me, Tirta Jayanti.
In this video, we will learn about series and sequence. Hope you guys enjoy! Sequence and series is one of the basic topics in arithmetic. An itemized collections of elements in which repetitions of any sort are allowed is known as a sequence, whereas series is the sum of all elements. In the previous video, we have learned about sets. Series and sequence are very similar to sets, but the primary difference is that in the sequence, individual terms can occur repeatedly in various positions. The length of a sequence is equal to the number of the terms, and it can be either finite or infinite. Now, do you know what is a sequence? A sequence is an arrangement of any objects or a set of numbers in a particular order followed by some rule. For example, 3, 5, 7, 9, blank blank blank. In this sequence, 3 as the first term, 5 as the second term, 7 as a third term, 9 as a fourth term, and the 3 dots means goes on forever or infinite. How can we know the sequence is finite or infinite? Now, when the sequence goes on forever, it calls an infinite sequence. Otherwise, it's a finite sequence. For example, 1, 2, 3, 4, blank blank blank. It is a very simple sequence and it is an infinite sequence. 1, 3, 5, 7 without a blank 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 as the sequence of the first 4 odd numbers, and it's a finite sequence. Just like what I've been explaining before, a sequence is very similar to set. A sequence is like a set, except first, the terms are in order, or with sets order does not matter. And second, the same value can appear many times. The same value only once in sets. For example, 0, 1, 0, 1, 0, 1, blank 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 is the sequence of alternating zeros and ones. Then sets, it is just 0, 1. Next, how about the notations of the sequence? Sequence also use the same notations as sets. List each element, separated by a comma, and then put curly brackets around the whole thing. You can see the example in this slide. The curly brackets are sometimes called set brackets or braces. How about the rule? A sequence usually has a rule, which is a way to find the value of each term. For the examples, the sequence 3, 5, 7, 9, blank 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 start at 3 and jumps 2 every time. For the specifics, you can see the picture in this slide. Saying start at 3 and jumps 2 every time, it's fine. But it doesn't help us to calculate the 10th term, 100th term, or nth term, where n could be any term number we want. So, we want a formula with n in it, where n is any term number. So, what can a rule for 3, 5, 7, 9, blank 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 be? Firstly, we can see the sequence goes up 2 every time. So we can guess that a rule is something like 2 times n, where n is the term number. Let's test it out. You can pay attention to the table. If we use 2n as the rule, we can get 2, 4, 6, and that's nearly work, but it's too low by 1 every time. So let's us try changing it to n plus 1. You can pay attention to table again. If we use 2n plus 1 as the rule, we can get 3, 5, 6, and that's work. So instead of saying start at 3 and jumps 2 every time, we can write this 2n plus 1. Now we can calculate, for example, the 100 term. We can change the n with 100. So we get 2 multiplied by 100 plus 1 equals 201. To make it easier to use the rules, we often use this special style, un. Un is the term, and n is the term number. For example, to mention 5 term, we write U5. Now, let's look at special sequence and their rules. The first, we have arithmetic sequence. In an arithmetic sequence, the difference between one term and the next is constant. In other words, we just add some value each time on to infinity. For example, 1, 4, 7, 10, 13, 16, 19, 22, 25, blah blah blah. This sequence has a difference of 3 between each number. Its rule is un equals 3n mean 2. In general, we can write an arithmetic sequence like this: a plus d, a plus 2d, a plus 3d, blah blah blah, where a is the first term and d is the difference between the terms, or we can call the common difference. And we can make the rules: un equals a plus d multiplied by n mean 1. My partner, we will continue to explain the next special sequence.
Now I will explain about geometric sequence. In a geometric sequence, each term is found by multiplying the previous term by a constant. For the example, 2, 4, 8, 16, 32, 64, 128, 256, blank blank blank. This sequence has a factor of 2 between each number. Its rule is un equals 2 to the power of n. In general, we can write a geometric sequence like this: a, ar, ar squared, ar cubed, blank blank blank, where a is the first term and r is the factor between the terms, or called the common ratio. For the note, r should not be 0. When r is 0, we get the sequence a, 0, 0, blank blank blank, which is not geometric. And we can make the rule un equals ar to the power of n minus 1. Next, triangular numbers. The triangular number sequence is generated from a pattern of dots which form a triangle. For the example, you can see the picture in the slide. By adding another row of dots and counting all the dots, we can find the next number of the sequence. But it's easier to use this rule. un equals n multiplied by n plus 1 divided by 2. For the example, the fifth triangular number is u equals 5 multiplied by 5 plus 1 divided by 2 is 15. And the sixth is u6 equals 6 multiplied by 6 plus 1 divided by 2 is 21. Next is square numbers. For the example, 1, 4, 9, 16, 25, 36, 49, 64, 81, blank blank blank. The next number is made by squaring where it is in the pattern. The rule is UN equals n squared. Okay, next is cube numbers. For the example, 1, 8, 27, 64, 125, 216, 343, 512, 729, blank blank blank. The next number is made by cubing where it is in the pattern. The rule is UN equals n cubed. And the last one is Fibonacci sequence. For the example, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, blank blank blank. The next number is found by adding the two numbers before it together. For the example, the 2 is found by adding the two numbers before it, 1 plus 1. And the 21 is found by adding the two numbers before it, 8 plus 13, etc. The rule is UN equals UN minus 1 plus UN minus 2. Now I will explain about series. What is the series? The series is a sum of the members of a sequence. For the example, 3, 5, 7, 9, blank 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 is a sequence. Then 3 plus 5 plus 7 plus 9 is a series. Arithmetic series. An arithmetic series is an addition between the term of an arithmetic sequence. The sum of the first term to the nth term of the arithmetic sequence can be calculated as Sn equals U1 plus U2 plus U3 plus blank 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 plus UN minus 1. The series sequence for the first n terms is denoted by the letter Sn and has the following formula. Sn equals n divided by 2 multiplied by 2a plus n minus 1 multiplied by d, where Sn is number of n first term, a is the first term, d is different, and n is many terms. For the example, find the series sequence for the first 10 terms of the following arithmetic sequence: 1, 4, 7, 10, 13, blank blank blank. Solution: the values of a, d, and n are: a is 1 because the first term is 1, d is 3 because the common difference between terms is 3, n is 10 because many terms to add up is 10. So don't forget the formula. Sn equals n divided by 2 multiplied by 2a plus n minus 1 multiplied by d becomes S10 equals 10 divided by 2 multiplied by 2 multiplied by 1 plus 10 minus 1 multiplied by 3, and we get the result S10 is 145. You can add up the term yourself and see if it comes to 145.
Okay, that's enough for this video. Don't forget to like, comment, and subscribe. And see you in the next video.